Hi, welcome back. Welcome to Unacademy. All of you know that Unacademy is the India's largest online learning platform. I'm welcoming you all to this beautiful online learning platform. Now we are happy to announce that we are going to start GATE and Engineering Service Examinations training. Okay. Now we are welcoming you all to this beautiful learning platform. About myself, I G Venkata. I have 16 plus years of teaching experience. So far I mentored more than 60,000 students for their GATE examinations. And at present I am pursuing PhD from JNTU Kakinada. My specialization is VLSI design. Now, first we check how to get the Unacademy learning app into our device. Just go to Play Store. There type Unacademy. Then you get the Unacademy learning app with this emblem like this. Okay. Now in this, just click on this install button. By clicking on this install button, it will install the Unacademy learning app in your device. Okay, and after installation, once you open the device, once you open this app in your device, it will shows what are the different courses available in that, and in each course who are the top educators handling the subjects in that course. Okay, everything you get in that, everything you get. Okay, now you observed once the educators who are handling the subjects in this, they are the top educators and they are having most experience. They are having more than 10 years, more than 8 years. Okay, and few of the faculty are from IIT background. Most of the faculty, okay, they are the toppers. So here let us take an example. Here I am showing some faculty. Or Tiwari sir, he is the IIT topper, and Ankit Goyal sir, he got 2 times All India first rank in GATE Electrical, and he got President of India Gold Medal in IIT Indore. And Jaspal Singh sir, he is the ex-IAS officer. His rank is All India 4th rank. And Sanchit Jain sir, he is the top computer science faculty. He has more than 8 years of experience. Okay, so this much, this type of faculty, this type of educators are available here. Okay, so you get the more benefits by joining in this. Now here few more educators are available. Okay, now we are happy to announce that we started a new batch for GATE 2023. There is a Ascend batch. Batch started from 8th February 2021. Again mechanical, and for mechanical itself, 8th February 2021 another batch started for GATE 2022. For civil engineering, there is a batch, Ascend batch for GATE 2021-23. It is started from 8th February. And so same 8th February, this is civil engineering, there is another batch for GATE 2022. And for recent GATE 2022 and 2023, we started a new batch for mechanical GATE 2022 and 2023. It is starting from 22nd of February. From 22nd February 2021, we started a new batch. Okay. And for computer science and engineering, there is a evolve batch for GATE 2022. And for electrical engineering, there is a Ascend batch for GATE 2023. This batch started from 1st February 2021. Next, for 1st February 2021 itself, there is electrical department batch, ECE batch started. So these are the top faculty who are handling the classes in that. And again, there is a evolve batch for GATE 2022. This time this is for electrical engineering. This batch started from 1st of February, and there is a eval batch for GATE 2022 ECE. This batch started from 1st of February 2021, and there is a chemical engineering. For chemical engineering, there is a batch 22 GATE 2022. There is a new batch started from January 25th. Okay, this is for chemical engineering. So you must thank to chemical engineering faculty and academy because they provided such a beautiful facility to you. At outside, it is very difficult to get the faculty from chemical engineering. They gathered the top faculty from India, and they are providing the best facility to the students by online. You observed throughout India hardly one or two places you get the training for chemical engineering GATE. Okay, but so in that case, what happens generally, students are moving from different locations of India to only that one or two locations. Okay, they have to leave their job, they have to take a leave from their job, who are employees, and during third year and final year they are taking leave from college, and 1 or 2 months they are attending there. So like these problems are there. Now no need to move like that. From India's top educators, you are getting the training in an academy. Okay, so now we are welcoming you all to this beautiful online learning platform. Now once again I am going to showing what are the different disciplines available for GATE and engineering service examinations. Mechanical engineering, electrical engineering, civil engineering, production and industrial, instrumentation engineering, chemical engineering, computer science and IT department, and last but not least, electronics and communication engineering. Electronics and communication engineering. Now we have two subscriptions. One is a plus subscription, other one is iconic subscription. One is plus subscription, other one is iconic subscription. In plus subscriptions, India's best educators are going to handle your classes. There are interactive live classes, structured courses and PDFs, live tests and quizzes, and India's best educators are going to handling your classes in iconic also. There are interactive live classes, structured courses and PDFs, live tests and quizzes are there in iconic. Now the best thing in iconic is we are taking your preparation for GATE and service examination to a next level with personal coach. Here we are going to provide a personal coach to you. Okay, we are providing a personal coach to you. The purpose of the providing personal coach is what are the examination you've written, whatever the GATE examination you've written, that GATE examination tests what you are writing. Before going to writing the final exam, you are writing some exams, online tests. So that exams are going to be analyzed by the personal coach, and where you are writing properly, which topics and which subject you are strong, where you are doing mistakes, and where you need much preparation, where you need much training. They will note everything, they will prepare. Okay, and that information is designed in a proper way as a study planner. Okay, by providing that one to you, okay, and with proper material, whatever the gaps you have, gaps in your preparation, we will fulfill those gaps. Okay, so we will fulfill those gaps. Now that is the intention to provide the personal coach, and here we provide a proper study material also to you. Now just we check the plans once again. Here you check in class plan, there is a 1 month subscription, 3-month subscription, 6-month subscription, 12-month subscription. Okay, different subscriptions are there. So the cost of 1 month subscription is 5,500. For 3 months 13,750, and 6 months this much, and 1 year this much, 1.5 and 2 years. As a faculty, I recommend the students to take minimum of 1 year subscription. Minimum of 1 year subscription. Okay, so why it is this 1 year is minimum, 1 year is required for a student to completely listen the class, understand the subjects, practice the subjects more number of times, repeat the subject, revision, and write more number of examinations, and identify the gaps where they have, and to fulfill those gaps and to be ready to the examination, minimum 1 year is required. So that's why, my dear students, please take minimum 1 year subscription. Okay, and by using my code VRAW10 during subscription, you get it by 27,225 rupees only. 10% discount. With the 10% discount you get it. Okay, now we are moving to iconic plan. Okay, in iconic plan, there are two subscriptions. So 1 year subscription and 2 year subscription. For 1 year subscription, it is 50,250 rupees. With a 10% discount, you get it by 45,225 rupees. 45,225 rupees. Okay, so by using my code VRAW10, and one more thing, we are charging this much amount only for guidance. We are providing a personal coach regularly. He is going to verify your preparation, what about your study planner, what is your preparation going on, how much you are going to be attaining that. Okay, everything he is going to continuously monitor you and continuously verify your preparation, and they make you ready for writing the examination in an effective way. Okay, throughout year, that is. Okay, so my dear students, whatever the thing is happened at outside, our learning process should continue. It cannot stop or it cannot break. Okay, now you know that at outside situation at present what happens, already now few more states are going to again lockdown. Okay, in this pandemic, please think once of it. Be stay at home, stay safe. Okay, and keep on learning. Okay, thank you. Now we are moving to concept. Our today's topic is a concept through problems on PN-Junction Diode. Now we solved some problems on PN-Junction Diode, some important model problems on PN-Junction Diode. At the same time, once we discuss and we revise the topics on this. Okay, so that is the intention here. Now this is this first problem. So what is your first problem? Let's see this. Is consider a PN junction consider a PN junction diode at room temperature having following parameters. Doping on n side 1 into 10 power 17 per centimeter cube. Doping on n side is doping on n side means it is our ND. So ND value given it as 1 into 10 power 17 per centimeter cube. Similarly, the depletion width on n side, depletion width on p side 1 micrometer, intrinsic carrier concentration, thermal voltage, permittivity of free space, dielectric constant is 12. Built-in potential they want, and peak electric field. They did not mention any information related to the biasing. It means your diode is under open circuit condition. So you can take it as the next one is a depletion width on PN side is xn naught. So that is a 0.1 micrometer. Okay, now I am changing this one to centimeters. So 0.1 into 10 power minus 4 centimeters. So that is a 10 power minus 5 centimeters. Similarly, they given at the same time depletion width on p side xp naught. They given it as 1 micrometer. So it means 10 power minus 4 centimeters. And Ni value they given, Ni 1.4 into 10 power 10 per centimeter cube. And thermal voltage means it is Vt. Vt they given, it is a 26 millivolts. And permittivity epsilon naught, free space they given, dielectric constant 12. See, first we calculate epsilon. This is silicon diode. Default PN junction diode is silicon. For that, epsilon value is epsilon naught into epsilon r. Okay, now just I am calculating this. Epsilon naught value 8.854 into 10 power minus 12 farad per meter. Okay, now I am changing that in terms of centimeters. 1 meter 10 power 2 centimeters. Now it became 10 power minus 14 centimeter farad per centimeter into, they given 12 but actual value is 11.7. Actual value is 11.7. Once it is 10 power minus 14, by multiplying with 11.7 or 11.12, it is not much deviation, not much difference. So I am taking 11.7 because I want to design, give a perfect value for this. Now see 8.854 into 11.7, or you can take 12 also. It is 1.03 into 10 square. 1.03 into 10 square means it is a 10 power minus 12 farad per centimeter. If I am using, instead of this, if I am using 12, that is 12 into 8.854. See, that is 1.06. If I am using, instead of this, if I am using a 12, you get 1.06. Okay, 1.03 or 1.06, we can take it as approximately 1 into 10 power minus 12 farad per centimeter. So my dear students, now onwards we are going to using the epsilon value as 1 into 10 power minus 12 farad per centimeter. Okay, this is the given data. So far we collected the given data. Now what we have to calculate? We need to calculate first built-in potential. So we know that built-in potential VBI, here we are representing it as V0, contact potential, it also called as, we know the value of it. It is a Vt into ln of Na Nd by Ni square. Na Nd by Ni square. Okay. See, basically we derived this equation from law of junction. Once you check the law of junction, so this is the law of junction. Law of junction is Pp is equals to Pn into e power V0 or built-in potential by Dt. This is the law of junction. We get this equation by equating the current through semiconductor or PN junction equals to 0, because your diode is under open circuit conditions here. By equating drift current plus diffusion current of holes equals to 0, we got this relation. This is law of junction. From this we can write V0 is equals to Vt into ln of Pp by Pn. Here Pp is the concentration of holes on P side, Pn is the concentration of holes on N side. But we know that concentration of holes on Pp is nothing but a amount of doping on P side, that is Na, and Pn is concentration of holes in N side, that is Ni square by Nd. Just here I applied mass action law. Now finally V0 is Vt into ln of, substitute Pp, Na, by Pn, Ni square by Nd, Ni square by Nd. This is the equation. This is the equation for V naught. Vt into ln of Na Nd by Ni square. So that was this. Vt into ln of Na Nd by Ni square. Just to take the values, substitute here. Here Nd they given, but okay, Ni they given, but we don't know the value of Na. To calculate Na, I am going to using one equation, that is, so here, before going to that, what are the concept we are applying here is, already we plot the electric field. So this is the electric field plot. This is the electric field plot. Okay. This is E, electric field, and its value is minus xp naught, and this value is xn naught. This is 0, and this is the maximum electric field E naught. So the electric field is maximum at junction. Electric field is maximum at junction. Now this is the direction of it. Now what are the electric field here you mentioned? I am going to be representing this one by an equation. Now we derived already equation for this electric field. So the equation for electric field E is equals to minus Na into Q by epsilon into xp naught into 1 plus x by xp naught. This is the equation for x value is, so 0 less than or equals to x and less than or less than, sorry, is minus xp, sir. Minus xp less than or equal to x and less than 0. Similarly, which is that means from here to here, minus xp naught to 0, its value is this much. From 0 to xn naught, its value is Nd into Q by epsilon into xn naught into 1 minus x by xn naught. Okay. So this is for x value greater than or less 0 less than or equal to xn naught. Okay. These are the equations for electric field. Now electric field is maximum at junction. Both are representing the same function. So electric field is maximum at x equals to 0. So therefore electric field is maximum at junction. Electric field is maximum at junction. So once it is maximum at junction, I am going to substituting x equal to 0 here. So by substituting x equal to 0 here, therefore electric field at x equal to 0 is, from first equation, minus Na into Q by epsilon into xp naught, and from second equation, minus Nd into Q by epsilon into xn naught. From this equation, but both are representing the maximum value of a same function. Once both are representing same function, that means both should be equal. Now just I am going to equating this. By equating this, it is minus Na into Q by epsilon into xp naught is equals to minus Nd into Q by epsilon into xn naught. Just simplify this. Q negative epsilon gets cancelled. Now this is Na into xp naught equals to Nd into Xn naught. So this is the standard equation we have. Now from this equation we calculate the required value of Na from this in your problem. Now I'm going to using this. Okay, see. Now, yeah. Now, okay, second part we go this side. First part I'm going this side. Now, so our equation is Na into Xp naught equals to Nd into Xn naught. So we need Na, therefore Na is Nd into Xn naught by Xp naught. So Nd they given 10 power 17 into Xn naught 10 power minus 5 by Xp naught 10 power minus 4. So it is 10 power 16 per centimeter cube. This is the Na value. Just take this Na and Nd, substitute in that problem, in that formula. Therefore, V naught equals Vt, they given already 26 milli. So you can take directly, it is a 0.026 into ln of Na Nd 10 power 16 into 10 power 17 by Ni square 1.4 into 10 power 10. They given already Ni value 1.4 into 10 power 10 into 1.4 into 10 power 10. So that is 0.026 into ln of. So it is 10 power 10, it is 10 power 10. So now it is a 10 power 13. Like it is a 10 power 13 is left. Okay, now you can take it as a 10 power 12, 10 by 10 into. So now it is a 10 divided by 1.4 divided by 1.4. It is 5.1. So 5.1 into 10 power 12. Sorry. So now it is P naught is 0.026 into ln of this value is a 1.62 plus 12 into ln of 10 is 2.3. Just simplify this. Now 12 into 2.3 27.6 plus 1.62 into 0.026 0.759 0.759 volts or approximately 0.76 volts. So this is the value. This is the built-in potential V naught 0.76 volts. Now just we go and check the options. Yeah, see this here, there is a 0.76 volts. So this is the answer. Okay, next problem. The peak electric field in the device is, see they given different options, a directed from P to N and a directed from N to P, directed from P to N, directed from N to P. So we know that the electric field is a directed from N to P. So always electric field is a directed from N to P. So this is P region and this is N region. So electric field is directed from N region to P region. So either option is a B or D, either B or D. Now we need to calculate peak electric field. That means this is the value you need to calculate. So we have two values for that, minus Na into Q by epsilon into Xp naught or minus Nd into Q by epsilon into Xn naught. Okay, just use any one of that. Therefore peak electric field E naught is minus Na into Q by epsilon into xp naught is minus Na value. Na is 10 power 16 we got. Q 1.6 into 10 power minus 19 by epsilon 1 into 10 power minus 12. Xp naught value. So xp naught 10 power minus 4. So 10 power minus 4. Yeah. Now just simplify this. This one cancelled in this by, now it is a 10 power minus 3. Minus 3 it is 7. Now it is a 10 power minus 5. 1.6 into 10 power minus 5. 1.6 into 10 power minus 5. You can write it as, it is a volt per centimeter. Or it is 10 power plus 5. Now it is a 0.16 into 10 power 6 volt per centimeter, or 0.16 megavolt per centimeter, because they given options in the terms of megavolts. Okay, now value is 0.16 megavolt per centimeter. See 0.15, 0.15, 1.8, 1.8. So these two are not match, either this one or this one. But in this director, it is a director from N region to P region. That's why option is B. So the option is B. Okay, so here just we calculated the electric field value, and from that we identified the maximum electric field. Okay, just we substituted the value in that. Next one. So we move to next one. Like this you have to solve the problems. Now we move to next problem. Yeah, it is also same. It is also based on the electric field. See this problem first. The electric field profile in the depletion region of a PN junction in the equilibrium is shown in figure. Which one of the following statement is sorry sorry sir. So the given electric field profile on a PN junction, and which one of the following statement is not true? That means not true means false statement. You have to calculate, identify false statement. So now this is electric field. This is the extension of depletion region one side, extension of depletion region on another side, of the order of micrometers. Now if you observe the plot, just before we draw the plot, this is the plot what we know. Okay, this is the electric field plot what we know. This is a noun plot. Noun plot. So it is a xp naught. This is like this. That means here this side, this one. So this is minus E naught. This is the electric field plot. It is minus xp naught. It is xn naught. This is the plot what we know. And this side is, it is the P region. It is N region. It is having a negative slope in P region and positive slope in N region. Extension of depletion region on P side is minus xp naught. Similarly, extension of depletion region on N side is xn naught. This is the noun data. We know this one standard form. They given the plot different way, simply opposite. Now we need to identify the given data first. Now from the in this side, left hand side, this is going to be plot is slope is increasing, and right hand side slope is decreasing. So once slope is increasing, positive slope, it is n region, it is n region because of positive slope. This side it is a p region because of negative slope. Okay, and it is the extension of depletion region xn naught, it is the xp naught. Okay, okay sir. Now xn naught is 0.1 micrometer and xp naught is 1 micrometer. That is the given data. And maximum electric field E naught they given as 10 power 4 volt per centimeter. Volt per centimeter. This is the given data. So this is the data we know from plot what they given. See, now they are saying the left side of the junction is N side and the right side of the junction is P side. Yes, it is true statement. It is true. Both and N type and P type depletion regions are uniformly doped. Yes, whatever the junction we taken default is a uniformly doped junction. It is uniformly doped one. Okay, because of uniformly doped only, the electric plot is like this. Yeah, it is true. Now the potential difference between across the depletion region is this much. Potential difference means contact potential, sir. We are saying they are saying it as a contact potential V naught. Okay, later we go to that. For contact potential we need to do more calculation. Now we check the fourth option first. If p type region is doped 10 power 15, p type region is doped 10 power 15, that means Na is 10 power 15. If Na is 10 power 15, then the doping concentration in the N type region will be 10 power 16. Now Nd is 10 power 16 per centimeter. This is the second statement. Now we check and substitute these values here. From this, already just before in previous problem we calculated one, we derived one equation, that is a Na into xp naught equals to Nd into xn naught. From this we can write Nd is equals to Na into xp naught by xn naught. Now Na value is, now they are saying if Na is this much, okay, I am taking that value 10 power 15 into xp value is 1 micro by xn naught 0.1 micrometer. Now this one cancelled in this by 10 times. Now it is 10 power 16 per centimeter. So if you are taking Na of 10 power 15, then you are getting Nd is 10 power 16. So the same thing you are getting. So this is also true statement. Now this is the false statement. It is false statement. Okay, because you observed or not, in this problem they did not given any Ni value and they did not specify even type of semiconductor. They did not mention the type of semiconductor, silicon or germanium, they did not mention. Okay, if they mention, then you can take Ni value something, because from this you get the Na-Nd value. From this you get the ratio of Na-Nd. Okay, now so from this problem so much information is available in this from this plot. Okay, so my dear students, please practice this type of problems. There is a chance of getting the problems like this. Okay, now we are moving to a next problem. See, so consider a silicon PN junction at T equals to 300 Kelvin with the doping concentration Na is 10 power 16 per centimeter cube and Nd equals to 10 power 15 per centimeter cube. The built-in potential barrier is 0.635 volts. The space charge width in micrometer is, sir, space charge width means depletion region width is how much? See, and they given epsilon or 11.7 and permittivity value. So from this two, immediately you write epsilon value, which is 1.03 or 04 into 10 power minus 12 farad per centimeter. So you can take the approximate value, it is 10 power minus 12 farad per centimeter. That is the epsilon value. Okay, so you need to calculate the depletion region width. Okay, from already we just before we calculated the electric field. This is the electric field plot what we completed just before. So this is the electric field plot what we completed. So this is the W naught depletion region width. Extension of depletion region width on P side XP naught. Extension of depletion region width on N side XN, sorry, it is minus XP naught. It is XN naught. XN naught. This is E naught. E naught. Okay. Now here we need depletion region width. Now here E naught is the maximum electric field. Okay, now first I am going to calculating the electric field. There is an equation for electric field, E is equals to minus dV by dx. Okay, we know that. From that I am writing dV is equals to minus E into dx. Now I am taking the limits on both sides. Limits on both sides. Now dV, now limits should be in terms of voltage. So let us Vp naught to Vn naught. Potential at P side to potential at N side. And dx minus xp naught to xn naught. Minus xp naught to xn naught. So from this, and we know one thing, there is a potential difference from P side to N side. Now that is a Vn naught minus Vp naught is called as contact potential difference or built-in potential VBI. Okay, now from this we can write by integral dV is V, by applying limits it became Vn naught minus Vp naught is equals to minus integral minus xp naught to xn naught into E into dx. That is the plot. Now it is nothing but a V naught. So from this we can write simply V naught is equals to minus of integral minus xp naught to xn naught in E dx. But if you observe one thing, this is nothing but the thing what you are mentioned here, this is nothing but a slope of, sorry, area of electric field E. Area of electric field E. So it is in the form of a triangle. Now I am writing V naught is equals to, therefore V naught equals to minus, V naught equals to minus slope of area of this, it is a triangle, area of triangle is half into base W naught into height E naught. Now we know the value of E naught already, just before we derived it, minus NA into Q by epsilon into XP naught. Okay, now V naught value is, it is a minus minus plus, so W naught into NA into Q by 2 epsilon into XP naught. we have an equation for xp naught, that is a w naught into nd by na plus nd. We get this one just by equating w naught equal to xp naught plus xn naught. Okay, and we derived an equation na into xp naught equals to nd into xn naught. By equating those and simplifying that, you get this one. From this equation we get the by simplifying this, just take w naught square, the remaining things take this side, then you get it as finally depletion region width w naught equals to square root of 2 epsilon by q into 1 by na plus 1 by nd into contact potential v naught, 1 by na into contact potential 1 by na plus 1 by nd into v naught. Now I am going to using this expression. This. So depletion region with the w naught, just before you mention square root of 2 epsilon by q into 1 by na plus 1 by nd into v naught. So v naught is nothing but a built-in potential vbi. Just substitute the values. 2 epsilon is 10 power minus 12 by q 1.6 into 10 power minus 19 coulombs into 1 by na 1 by 10 power 16 plus 1 by nd 1 by 10 power 15 into built-in potential is 0.635. Just simplify this. Square root of, so this is 2 and this is 0.8 times 12, it is 10 power minus 7. Okay, so 0.635 by 0.8, that is 0.79, 0.79 into taking 1 by 15 common and 1 by 10 power 15 common, so then it is 1 by 10, 1 plus 1 by 10, 1 by 10.1, 1.1 to 1.1. This is the value. Now it is into 1.1, 1 by 10. Now square root of this, it is 0.29 5 by 5 into 10 power minus 7. Okay, so this is the value. So they want in terms of micrometers. This is in centimeters. In micrometers, if you want, in micrometers, 1 micrometer is 10 power minus 4 centimeter. Okay, so 0.29, okay, you can take it approximately 0.3, 0.3 into 10 power minus 3 micrometer. Micrometers they want. Okay, so this is the equation value 0.3. so no option is matching, there is a mistake in the matchings options. Okay, so like this you can calculate. So 2 by 0.8 times, okay, we check calculation once again. 0.635 divided by 0.8, yeah, 0.79, okay, it's correct, into 1 plus 1 by 10, 0.1, 1.1 into 1.1, 0.87, square root of 0.87 Just a minute, sir. 0.87 we got. Okay, 1.1 into 0.79 divided by square root of that. Yeah, point. So, sir, just a minute. Here, okay. Small mistakes, sir, nothing. Procedure is same, we done. And here it is this one into this one 0.79 into this is 1.1 by taking 10 power 15. Once you taken 10 power 15, 10 power 15 into 10 power minus 7. Yeah, into 10 power minus 7. This is the value. This is the value. So 0.79 into 1.1. So square root of that is 0.932, 0.932 into 10 power 8 it is. So it became 10 power minus 4. Okay. So 10 power for minus 4 centimeters. Now it is a 0.93 micrometers, because 1 micrometer is equals to 10 power minus 4 centimeters. Already we know that. So now this is the option, 0.93 micrometers. Yeah, closest value is 0.95. This is the closest value. Okay, sir. See this, even though we done everything same due to little bit modifications, little bit just we forgot this 10 power minus 7. Be careful. See, even though we know this problem very well, but we done some mistake in the calculation. So please, my dear students, concentrate on this type of things also. So once, twice, thrice you need to check it. Okay, once my answer is not matching, you need to go back and check once again. Thank you. Now we move to next problem. Consider a PN junction. Consider a silicon PN junction. Clearly they mention, sir, it is a silicon with the doping concentration Na 10 power 16 and Nd 10 power 15. The built-in potential, okay, already we calculated this one just before. This is the depletion region which we got. In above problem, determine the electric field intensity at the junction. So in this problem, they want electric field intensity, sir. That means maximum electric field. You know that. Minus Na into Q by epsilon into xp naught. Okay. Or we know one more thing. Just before in the previous equation we've written contact potential V naught is slope of that, area of that, half into base into height E naught. Half into base into height. So that too height is E is negative. E is negative minus. Therefore electric field E naught, maximum electric field is minus 2 into V naught by W naught. So just before we draw this, yeah, here we written V naught is minus 1 by 2 into W naught into E naught. This is the expression I am going to be using for this problem. Okay, V naught is minus 1 by 2 into W naught into E naught. Minus. Now, just substitute the values. Minus 2 into V naught already they given 0.635, 0.635 by W naught we calculated 0.93 microfarads. It is in terms of centimeters, so I am taking into 10 power minus 4. Okay, minus 4 centimeters, because in micrometers it is already, I converted that micrometers to centimeters. Now just simplify this. minus, I'm simplifying this, 2 into 0.635 divided by 0.93 0.93 1.36, so which is 1.36 into 10 power 4 volt per centimeter. This is the answer. Okay, so 1.36 minus, this is the closest value, this is the closest value, 1.34 into 10 power 4. Okay, here we taken whatever the value we got, 0.93 we taken. Okay, but they considered this one, that is the only difference. If you consider that, you get exact value. Check that one also. 2 into 0.635 divided by 0.951. Yeah, 1.33 we are getting. So 1.3354. So 1.34. Whatever it is the closest value. So like this, we calculate it. Now you observed or not? So this is the actual equation for E naught. In this case, what we need to do is, once you note the W naught, they given NA, Q and epsilon. If you want XP naught, you need to go for this, use this formula. XP naught is a W naught into ND by NA plus ND. This equation you need to use. Okay, so again, see, we can get finally answer, it's not an issue, but the problem here is time, amount of time, how much you are spending for that. See, from this directly we got the equation, only one calculation, just 2 into V naught by W naught. V naught already they given, W naught we calculated, only two parameters we need to use, but in this case 1 2 3 4 5 6 parameters we need to simplify, but here only two parameters. So simplification process is decreasing here, that is the important thing. Okay, next, now we are going to next problem. A certain PN junction has a built-in potential 0.56 volts. If the Fermi level on N side is located 0.35 electron volts above the intrinsic Fermi level, what is the acceptor concentration on P side? Simple. See, what they given is a certain PN junction, built-in potential. So they given built-in potential or contact potential, we are calling it 0.56 volts. Sorry, 0.56 volts we are using. Next, in this, now I am writing the equation for this. This is nothing but a V naught value is Vt into ln of Na Nd by Ni square. I am taking this is a Ni into Ni. Now writing this is Vt into ln of Na by Ni plus Vt into ln of Nd by Ni. Just I am writing like this. Now this is 0.56, this is Vt. Now I am writing this equation like this, 0.56 volts into Q is equals to, here Vt is Kt by Q. So I am taking this Q this side, now it became a Q, Kt into ln of Na by Ni plus Kt into ln of Nd by Ni. Now it became 0.56 electron volts. Now see, they given Fermi level on N side located. Okay, N side located, this one. Now it is a Kt into ln of Nj by Ni, and this is the equation we know that from semiconductors. This is nothing but a EFN minus EFI, location of N-type semiconductor Fermi energy level with respect to intrinsic Fermi energy level. See this, if Fermi level on n side located 0.35 electron volts above the intrinsic Fermi level, that means they given EFN minus EFI is 0.35 electron volts. Yeah, that is nothing but this one. Just substitute that one here. Now I am substituting this one where this value here. Therefore 0.56 electron volts equals to kT into ln of Na by Ni plus 0.35 electron volts. Take this one this side. Therefore you get kT into ln of Na by Ni is 0.21 electron volts. And after this, take kT this side. KT value is we know that they given any value directly? No, they did not given. You can take 26 millivolts, milli electron volts. Therefore ln of Na by Ni is okay. So it is 0.21 by 0.026. So 0.21 divided by 0.026, that is 8. Now Na by Ni is e power 8. So now we are going to that e power 8. That is a 3.2 into 10 power 3. 3.2 into 10 power 3 into Ni. Therefore Na is 3.2 into 10 power 3 into Ni. So Ni they given 10 power 12, I think so. Yeah, 10 power 12. So this is 3.2 into 10 power 12 means 10 power 15 per centimeter cube. 3.2 into 10 power 15 per centimeter cube. So no option is matching. A minute. 0.56 minus 0.35. Yeah, 0.21. Fine. 0.21 divided by 0.026 is 8.0 e power of 8. It is a 3.219. 3.2 into 10 power 3. Yes, into 10. Okay, this is the correct option. It is the correct one. Sometimes they not match, sir. Don't worry. So this is a 3.2 into 10 power 15. Sorry, already they given 3.3 into 10 power 15. This is the option. Sorry. So like this, you need to solve the problem, sir. Okay. So please be concentrated on the concept. Once you are thorough with the concept, you can easily solve the problems. Okay. Now, thank you very much. Thanks for spending your valuable time with us. Next session we go and solve the remaining problems. Don't forget to use my code VRAO10 during subscription. By using this code during subscription, you get 10% discount. Don't forget to click on bell icon to get the notifications. Please subscribe us. Join our Telegram group to get the latest updates on our upcoming videos. And please give your valuable comments on our YouTube channel. Okay. Thank you very much. Once again, I am welcoming you all to this beautiful online learning platform, Unacademy. Thank you very much.